Space was predictable until the night it blinked. For centuries, the universe had been a system of obedience. Every orbit, every spin, every gravitational pull unfolded like a symphony written long before our species learned to listen. We built equations to measure its rhythm, instruments to catch its whispers, and telescopes to watch its eternal patience. Everything that moved did so for a reason. Until November 2025, when one small traveler refused to play by the rules. It was first logged by an automated scan from the Atlas survey in Hawaii routine. Unremarkable. Another distant light moving across the cold. But the computers flagged it differently. Its path cut through the solar system on a curve that no known comet should take. The catalogue assigned a temporary name, 3I Atlas, the third confirmed interstellar visitor humanity had ever recorded. At first, it seemed unimportant. We had seen wanderers before Oumuamua in 2017, Borisov in 2019. Strange, yes, but explainable. Visitors from the deep interstellar arcade, silent stones drifting between stars. But 3I, Atlas carried something else within its motion, an unease buried inside its mathematics. When the first orbital data came in, astronomers noticed a quiet misalignment. The acceleration didn't match gravity's pull. It wasn't falling, it was gliding. Tiny, almost imperceptible changes in velocity appeared in the numbers and then kept appearing, forming a pattern that shouldn't have existed. By December, observatories around the world began to confirm it. The JPL Horizons database updated its parameters again and again, refining what couldn't be refined, an object accelerating without force. In the language of physics, it was called non-gravitational acceleration. In the language of wonder, it was called impossible. Most comets do this, but in predictable ways. They vent gas and dust as sunlight warms their icy cores, producing jets that act like small thrusters. But 3I, Atlas showed none of those signs. No coma, no tail, no halo of vaporized ice shimmering in sunlight. It moved cleanly, almost deliberately through the dark. For the scientists at JPL, this meant only one thing: something was providing thrust that we couldn't see. The mathematical model broke down into three components, known as A1, A2, and A3, each representing a direction of acceleration. A 1 and a 2 had measurable values, but A3, the component that would indicate movement above or below the orbital plane, was exactly zero. Not small, not noisy, zero. That kind of precision doesn't happen in nature. It happens in machines. Imagine throwing a pebble into space and watching it accelerate in a perfectly flat line, with no drift, no wobble, no hint of chaos. That was the signature written into the orbit of 3I, Atlas. And then, almost poetically, the sun decided to speak. Within days of the first anomalous readings, the solar surface erupted. A colossal X-class flare tore through the heliosphere, sending plasma waves roaring toward Earth. The auroras brightened, satellites flickered, and communication networks trembled under invisible pressure. Hidden beneath that storm of electromagnetic fury, astronomers noticed something stranger still. 3I. Atlas shifted speed again right as the flare reached its peak. Coincidence? The rational mind said yes, but the timing was too precise to ignore. By January, discussion boards for astrophysicists were filled with unease. Someone compared the event timelines and found the same correlation across multiple instruments. Whenever the sun flared, 3I, Atlas moved. Whenever the sun slept, it coasted. The pattern repeated twice, then 3 times. If it was a coincidence, it was an elegant one. If it wasn't, it was communication. Observatories began pulling long nights. Teams from Chile, Arizona, Japan, and Australia tracked it around the clock. The light curve showed faint, rhythmic fluctuations, too regular for a simple tumble, too smooth for chaotic spin. It reflected light as if its surface were flat, perhaps metallic, or perhaps coated with something unknown that resisted heat. Telescopes on the Canary Islands detected a subtle polarization shift light scattering in a way that hinted at a uniform plane rather than a cloud of debris. The data didn't say engine. It didn't need to. The silence between the numbers spoke for itself. For every measured quantity, another question bloomed. Why did its brightness remain constant over so many observation windows? Why was its thermal signature cooler than expected for a body that close to the sun? Why was it accelerating outward instead of slowing down, as every natural body should when leaving the sun's gravitational well. Each time scientists asked those questions, they met the same unanswerable calm. It was as if the object had learned stillness from the void that carried it. Weeks turned into months. Most of the media ignored the story. It was too complex to sensationalize. But in academic corners, the debate deepened. Some declared it must be a fragment of an old comet, breaking apart under invisible stress. Others said it was a new category entirely, an object of non-classical behavior. He was not Fluster Case. And a few, quietly, wondered if it might not be natural at all. They didn't say alien, they said artificial. There is a difference, one born of caution, not fantasy. Artificial meant crafted, shaped, intentional. It meant that somewhere, perhaps far away, someone or something had made it, long before we were ready to notice. Still, no one dared to claim that openly. The scars from Oumuamua's controversy were still fresh. When Professor Avi Loeb proposed that Oumuamua could be a light sail, he was ridiculed by peers, dismissed by journals. Scientists learned the cost of asking questions that make the universe feel too alive. Yet 3I, Atlas, made silence harder to keep. Its trajectory through the inner solar system was elegant, almost rehearsed. It skimmed near Venus, drifted along Mars's orbital boundary, and pivoted subtly toward Earth's path before veering away as if aware of what it was avoiding. Each correction was small, almost shy, but mathematically perfect. Those who tracked it night after night began to feel it, that quiet intuition shared by every astronomer when the data starts to stare back. The object was moving, as though it knew it was being watched. It could be an illusion. Humans are built to see intention in randomness. But the symmetry was haunting. No comet, natural or otherwise, had ever behaved so precisely. Then, without announcement, the data flow stopped for nearly a week. Maintenance, some said. System update, but others suspected something less ordinary, perhaps a pause for verification, or censorship, or simple disbelief. When the system came back online, the numbers hadn't changed. The anomaly persisted. By 3I, Atlas was still accelerating, still in perfect plane alignment, still without visible cause. The universe had left us a riddle that fit neatly inside a single equation. Force equals 0, yet motion is not equal to 0. The paradox was complete. Across the quiet halls of observatories, scientists sat before screens filled with decimals and orbital plots. They could measure everything: distance, velocity, brightness, rotation, but not meaning. And meaning was the one thing that now mattered most. What is motion without force? What is a pattern without origin? For a moment, the line between physics and philosophy blurred, because maybe, just maybe, 3I, Atlas wasn't here to be studied. Maybe it was here to remind us that science begins not with knowledge, but with wonder. As the nights grew longer, the sky seemed to listen too. Every telescope pointed toward that dim traveler, an interstellar messenger that might not even know it was being called that. Its light was faint, but its silence was eloquent. And somewhere between those photons and our imagination, a question began to echo across every sleepless observer's mind. If this is just a comet, then why does it move like something that remembers its destination? The cosmos had exhaled, and in that breath, the pattern broke. Nothing in the heavens would ever feel entirely predictable again. Every comet stumbles in 3 dimensions. This one glides in 2. That was the first whisper of something extraordinary, too quiet to make headlines, too precise to ignore. Astronomers working with NASA's JPL Horizons database were the first to notice it. Their job, like always, was to process movement, charting the paths of asteroids, comets, and anything else that dared cross the solar system. Every known object gets a set of parameters, like fingerprints in motion, and 3I, Atlas, had just been printed. What they saw was not a mystery at first, just data. Clean, measurable, elegant. But inside that data were 3 numbers that govern the behavior of all non-gravitational forces acting on a comet. They're known as the A1, A2, and A3 parameters. Think of them as coordinates for invisible push, asterisk. A 1 measures acceleration in the direction toward or away from the Sunday, asterisk. A 2 measures acceleration sideways along the orbital path, asterisk. A 3 measures acceleration perpendicular to the orbital plane, up or down from the plane itself. In the real world, these values are never 0. A typical comet vents gas from unpredictable surfaces. Solar heat causes jets to erupt from its crust at odd angles, sending it wobbling slightly in all directions. Its motion, while smooth on a cosmic scale, is messy beneath the surface. The thrust is real, but uneven like a canoe being paddled by invisible hands from multiple directions. But not this one. For 3i, Atlas, the Horizons database showed something shockingly clean. Asterisk. A 1 equals measurable. Asterisk. A 2 equals measurable. Asterisk. A 3 equals exactly 0. Not nearly 0. Not close to 0. 0 within 5 decimal places. That meant something incredible. The object was accelerating only within its orbital plane, and not drifting above or below it by even the slightest degree. In the physical universe, where heat and gas flow and surface roughness create unavoidable chaos, that kind of control is unnatural. What they were seeing was motion constrained to a flat sheet, like a disc skating perfectly across a cosmic pond. It was like watching a bird flap its wings, but only along a ruler-straight path, never climbing or diving, never swerving off plane. No comet behaves this way. No rock, no rubble pile, no collection of ice and dust can produce exactly planar acceleration without some force correcting its drift. And that brought forward a terrifyingly elegant implication. The motion was being guided. The idea of non-gravitational acceleration is not new. It has explained strange motions in many comets before. Sunlight heats their icy surfaces, gas escapes, and Newton's third law does the rest. Action and reaction. These jets act like tiny rockets, altering the orbit just enough to be noticeable. But even in the best models, the acceleration is sloppy. A 3 is never 0. It fluctuates as sunlight hits different parts of a rotating body. Some areas vent more than others, some spin too fast, some lose mass. With 3i, Atlas, none of that happened. The body did not tumble the way it should. Its brightness curve suggested either a very slow rotation or something else entirely. Something flat, perhaps angled precisely to absorb energy in one direction. That's when scientists began to look closer at the possible thrust mechanisms. What could create motion only along the orbital path? What could eliminate vertical drift with such astonishing precision? They ran the simulations. They modeled jet positions, solar pressure variations, and crust outgassing profiles. Nothing natural worked. Every model that allowed for venting created drift non-zero A3. The only configurations that matched the data involved intentionally directed thrust. Not chaotic jets, not melting ice, but engineered symmetry. It was as though the object had gimbaled its thrust like a spacecraft compensating to stay aligned. For many, this was still not proof. It was an anomaly. Interesting, yes, but science is conservative, and rightly so. You don't change your understanding of celestial mechanics because one rock defies the odds. Except this wasn't the first rock. Oumuamua, the first interstellar visitor ever recorded, had done something similar. It too had accelerated without visible outgassing. It too had baffled models. It too had a strange, pancake-like shape that spun with regularity. But 3i, Atlas was cleaner, more precise. The thrust signal was unambiguous. And now, it had a clear orbital path, which allowed deeper calculation. JPL's models revealed that the object's course corrections happened in bursts, not continuous thrust, but discrete, gentle pulses of acceleration. Like nudges, like it was adjusting, like something or someone was piloting. The implications were enormous. If it were natural, we had discovered a new category of comet behavior, one that defied all previous thermodynamic models. If it were artificial, we were witnessing the first confirmed example of controlled interstellar navigation. And yet, we still had no visible evidence of propulsion. No jets, no ion trails, no exhaust. The only signal was motion. The only proof was math, and math, unlike the human eye, does not lie. In a meeting held in late December, a group of senior analysts quietly discussed whether to publish a revised classification. One proposed labeling 3i, Atlas, as a non-Keplerian transient, a fancy way of saying it doesn't follow the rules. But that label was rejected, not because it wasn't accurate, but because it was too honest, too soon. The internal debate mirrored something much older, a tension that had existed since Galileo first turned his telescope skyward. What happens when the heavens defy the system that interprets them? Do we change the heavens, or change the system? Some argued that calling this engineered was too speculative. Others said refusing to call it that was too political. Either way, the numbers refused to behave. By the 15th of January 2026, New data from the Cerro Paranal Observatory confirmed what JPL had seen. The object's A3 remained exactly 0 across 17 different observation windows. That was statistically absurd. That was a design signature. Of course, many in the community resisted this conclusion. For every astronomer whispering artificial, 5 others reminded the group that comets surprise us all the time. That sunlight can do strange things, that we must not leap ahead of the data. But this time, the data had leapt ahead of us. It wasn't only what we saw, it was what we didn't. Asterisk, no coma. Asterisk, no jets. Asterisk, no fragmentation. Asterisk, no variance in brightness. Asterisk, no vertical acceleration. Every normal signature was absent, and in its place was something unnatural stillness inside motion. A drifting object, perfectly flat in its trajectory, responding to energy like a sail catching wind, but never fluttering, never stumbling. Whatever 3i Atlas was, it wasn't just moving, it was gliding, and only in the plane that gravity allowed, like it had studied our models and agreed to play along just enough. A scientist at JPL reportedly remarked off-record, "It's like watching a ghost obey traffic laws." The word stuck, because what made 3i Atlas so haunting was not its speed, or its brightness, or even its origin. It was the silence between variables, the numbers that shouldn't exist, the vector that never blinked. A 3 equals 0. No comet has ever moved that cleanly. No force has ever acted that gently. And yet, here it was, a stone or something stranger, writing equations in the sky. And the equations refused to lie. It moves as if something inside it remembers momentum. No flames, no jets, no tail, and yet acceleration. In the language of the sky, movement demands a cause. Every comet we've ever observed has obeyed this rule. Solar heat melts ice, gases burst forth, the nucleus spins, stumbles, leaves a tail behind. There is friction, evaporation, outgassing, always some noisy, visible expression of the motion beneath. But 3i, Atlas drifts differently. It doesn't tumble, it doesn't shimmer with vapor. It glides. No visible thrust, no outflow, no debris trail, and yet the object accelerates with precision, gentle, predictable, sustained. The paradox is complete. Motion without evidence, force without fire. It would be easier to explain if we had never seen a comet before. The coma of a normal comet is its signature, a blooming haze of gas and dust that forms as sunlight strikes its icy core. That coma then feeds the tail a stream that stretches millions of kilometers behind it, pushed by solar radiation. It's not subtle. Even weak comets reveal their behavior. Their trails glow, their jets flicker, their outbursts, sudden increases in brightness can be seen from Earth. But when telescopes locked onto 3i, Atlas, they saw nothing. Not just no tail, no coma at all. Its silhouette against the stars was sharp, clean, no halo. No halo means no venting. No venting means no reaction force. And no reaction force means no motion unless something else is at work. But the motion is there, unmistakable. Even the most conservative models, stripped of interpretation, confirm the drift. A speed shift, a deviation from the gravitational path, a tiny but constant change in velocity. But no evidence of what caused it. Nothing came out. Nothing flared. Only silence, quiet and disciplined. Some suggested solar radiation pressure. After all, light itself carries momentum. Photons from the sun can push against surfaces just barely. Over time, the effect can accumulate. But even that model failed. Radiation pressure depends on the area-to-mass ratio. The object would have to be extraordinarily thin or lightweight to experience significant drift, like a sail. But no tumbling was observed, no changes in brightness, no signs of solar rotation effects. And besides, the observed acceleration was stronger than radiation pressure could produce unless the object was made of aerogel or spider silk. We know that's not how natural comets are built. Nature doesn't make sheets, it makes chunks. So that theory fell too. Others reached for gas vents hidden from view. Maybe the jets were on the far side, away from our telescopes. Maybe the coma was too faint to detect. But weeks passed, then months, and as it approached the inner solar system, the sun's intensity increased tenfold. Still no coma, no eruption, no outburst, just steady, quiet movement. At this point, a deeper pattern began to emerge, not in the object, but in the people watching it. They began to speak more softly, not because they were afraid, but because they were listening, as if the silence itself had become part of the data. There's a rule in science that dates back to Newton. For every action, there is an equal and opposite reaction. But 3I, Atlas, seemed to skip the reaction. It behaved as if it carried an internal memory of direction, as if momentum could be summoned, not pushed. Some began to whisper about non-local motion, the idea that an object could respond to external fields not through contact, but through structure. It's a fringe idea, one that hasn't found footing in mainstream physics. But fringe ideas tend to rise when old frameworks stumble. And here, something was stumbling. The observational instruments were solid, the trajectories confirmed. The silence, not an absence of measurement, but the measurement of absence itself. In that vacuum, the only remaining force was the unknown. In late January 2026, a paper was quietly circulated in a closed group of solar system dynamicists. The paper proposed a bold model. What if the thrust was internal, but not in the traditional sense? What if the object used internal mass displacement to shift itself forward like a squid without water, pulsing from within? Such a mechanism exists on Earth in the form of reactionless drives. All of them are theoretical, and all of them are controversial. But they share one trait. They defy conventional exhaust. They move without leaving a trace. The paper was dismissed publicly, but privately, it echoed. Because that's what this object was doing, moving without a trace. As pressure built, institutions hesitated to comment. JPL issued no formal anomaly report. The European Space Agency stayed silent. But individuals, retired physicists, independent orbital mechanics specialists began publishing informal breakdowns, and a pattern emerged in their language. They were no longer asking, "How is it moving?" They were asking, "Why can't we see how it's moving?" That shift matters, because it acknowledges something deeper. This isn't a gap in visibility, it's a gap in causality. A telescope in Tenerife captured a high-resolution light curve over 3 nights. The object's brightness oscillated, but not chaotically. It blinked almost rhythmically. One researcher noted, "It reminds me of a controlled pulse, like a heartbeat." That comment stuck, because motion without evidence becomes more than a technical puzzle. It becomes a character, a presence, a will. In our minds, we give the object intent, not because it has proven intelligence, but because everything else has been ruled out. That's how mystery works. Not by what it shows, but by what it refuses to show. And 3I, Atlas, refused us a flame, refused us a jet, refused us a trail. It gave us only effect, never cause. Only motion, never the hand that moved it. It became the question no model could finish, the silence no language could fill. And in that vacuum, speculation did what it always does. It bloomed. By February, fringe theories had migrated into respected channels. Not accepted but tolerated. Some said light sails. Some said electromagnetic interactions with the heliosphere. Others said dark matter disturbances. Each theory had a weakness. But each shared one thing in common. They admitted that the absence of evidence was not evidence of nothing. It was a signal, a door, not to an answer, but to a different kind of question. Because in all of physics, motion is the one thing that doesn't lie. You can argue about what you see, but you cannot argue with what moves. And 3I, Atlas, moved. Not like a comet, not like an asteroid, but like something that knew how to move without ever needing to show why. Not because it was hiding something, but because it never needed to explain itself to begin with. A force with no flame, a path with no push, a journey with no origin. And maybe, just maybe, an invitation to remember that not all engines burn. Some just begin, as if the cosmos had exhaled, and something remembered the direction. Every comet breathes light except this one. From the first telescopic glimpses of the object, known as 3I, Atlas, astronomers prepared themselves for a familiar show. The inner solar system is a stage, and comets, with their long, luminous tails and haloed bodies, are its most ancient performers. Every icy traveller that draws close to the sun plays the same role. It awakens. It exhales. It begins to shine. But this one remained silent. Still, a comet without its mask. The coma is not just an ornament. It's the sign of life. Cometary life, that is. As a comet approaches the warmth of the sun, its surface begins to sublimate. Ices turn to gas. Gases rush outward, carrying dust and fragments. This expanding cloud creates the fuzzy glow that surrounds the nucleus. A tail often forms as the solar wind pushes the coma material backward, sometimes stretching millions of kilometers into space. Even weak comets, those with small or depleted nuclei, manage to generate something, a shimmer, a haze, a sign that heat is at work. But when 3I, Atlas, approached perihelion, the point in its orbit closest to the Sun, the sky gave us nothing. No bloom, no trail, no haze. It passed through the region where other comets blazed to life, without changing expression. Professional and amateur observers alike watched with growing unease. This wasn't just a weak coma, it was a non-existent one. In late December 2025, instruments at Mauna Kea captured a high-resolution spectral reading. Normally, this would show water, carbon dioxide, or other volatiles escaping from the surface. But the data returned flat. Not quite flat. It was as if the object wasn't merely dormant. It was sealed, as if it had no breath to give. Other instruments confirmed the observation. No sign of cyanogen, a common component in comet comas. No methyl alcohol, no formaldehyde. Not even the faintest wisp of vapor. A telescope in Argentina took a deep composite over 8 nights, stacking long exposures. The background stars streaked, but the object remained a tight, clean point. No fuzziness. No expanding glow. A comet should shed skin. This one kept everything in. Some argued it was just too small to generate a coma, that perhaps the surface had already been stripped bare. But the problem wasn't just the lack of coma, it was the timing. This object was now in prime heating range. It had crossed the frost line. It was well within the inner solar system. Any natural nucleus with volatile materials should have responded by now. Even a few micro-outbursts would suffice. But the brightness curve remained steady, no flares, no gas-driven brightening. In short, no behavior. The deeper problem came from the contrast. We expected a living object. Instead, we got something inert, but still moving. It's like expecting a boiling kettle and finding a cold stone that whistles. There's something fundamentally unnerving about motion that isn't matched by emission. Energy must go somewhere. Cause must leave a trace. Except when it doesn't. One astronomer on an online forum posted this late at night. I feel like I'm watching a mime perform an opera. All the gestures are there, but the sound is missing. That metaphor stuck with many. Because 3I, Atlas seemed to go through all the motions, trajectory shifts, velocity adjustments, without any of the heat, dust, or gases that should accompany such changes. It was like watching an actor mouth words behind a soundproof wall. We see movement, we infer intent, but we hear nothing. The lack of coma sparked deeper suspicion. If this wasn't outgassing, what was it? A few began to model the object as an inert shell hollow, perhaps, or with active thermal shielding. Some whispered about a sail-like structure that reflected light, but absorbed little heat. Others turned to occultation data. Could the object be covered in a coating that simply prevented sublimation? Something metallic, something dark. But nature doesn't paint comets with mirror polish. And this object reflected sunlight with a curve too sharp for dust. A hard surface. A still surface. An engineered surface? We don't know. By January, a team at the European Southern Observatory published a strange note. The object's phase curve, a measurement of how its brightness changes, with viewing angle suggested an unusually flat surface. Most comets scatter light diffusely. Their irregular shape and dusty halo bounce photons in chaotic directions. But this one seemed to reflect with discipline, like a panel or a shield. Again, the word no one wanted to say became harder to avoid. This didn't look dead. It looked intentional. Of course, science doesn't work on implication. It works on evidence. And yet the lack of coma was evidence. Not proof of intent, but proof of absence. And absence, repeated and confirmed, becomes a kind of presence. A presence made of silence, of things not said, of light not bent, of vapor not exhaled. In astronomy, we're trained to think in contrasts. Light and dark, motion and stillness, presence and void. 3I. Atlas blurred those contrasts. It moved, but did not act. It changed course, but showed no effort. It responded to heat with indifference. And perhaps most disturbing, it was being watched and didn't seem to mind. A question began to form, one that would become more central with each passing week. What if this object doesn't need to behave like a comet? because it isn't one? What if it doesn't breathe because it doesn't need to? What if its silence isn't a failure of detection, but the design itself? In late January, the object crossed perihelion. This was the moment of truth, the closest point to the Sunday, the heat at its most intense, and still no coma. That moment, more than any other, silenced the final skeptics. This wasn't a weak comet. This wasn't an unusual outgasser. This was something else, and everyone tracking it knew. Whatever it was, it had just passed the line where nature speaks loudly, and instead, it whispered nothing. The coma never came. The light never bloomed. The breath never left its skin. Every comet breathes light, except this one, and in that breathless passage, we saw no emptiness, but a mirror held up to our expectations, a mirror that asked, what if the light we expected was never meant to come? What if this wasn't about brightness at all, but about how deeply darkness can travel? When it carries no signature but silence, nature makes noise. This silence feels designed. When astronomers talk about thrust, especially in the context of comets or interstellar objects, they rarely speak of control. Natural forces do not aim. They do not align themselves with invisible grids. But 3I, Atlas, did something that pushed beyond anomaly. It moved in a way that was not just impossible to explain, but mathematically clean. Its trajectory wasn't just strange. It was disciplined. The object was accelerating. That much was clear. But when the JPL Horizons data was processed, it revealed something far more precise. The thrust vector, an invisible arrow showing the direction of non-gravitational acceleration, stayed perfectly locked inside the orbital plane. In mathematical terms, that meant one thing: a 3 equals 0. No motion outside the plane, no deviation above or below, no chaotic wobble. Just a straight, controlled slide through space. To understand why this matters, we need to remember how natural comets behave. Their outgassing is messy, uneven, chaotic. Jets erupt from surface fractures, pushing in different directions. Sometimes one jet dominates, sometimes another. The result is a jittery, multi-dimensional push-pull across all three axes of motion. So when you look at the acceleration parameters, asterisk, a 1 usually measures push toward or away from the Sunday, asterisk. A 2 captures sideways motion within the orbital path, asterisk. A 3 reflects any deviation above or below that flat disk, the so-called ecliptic plane of the solar system. For 3I, Atlas, both A1 and A2 showed clear sustained values, but A3 was 0, not close to 0, not drifting, not averaging out, flat, precise, 0. That kind of constraint doesn't occur by chance. In fact, it's the opposite of what randomness produces. Comets behave like steam vents on spinning rocks. Their activity, though governed by physics, emerges from chaotic interactions between sunlight, surface texture, rotation, and composition. So even if a comet could somehow control its thrust slightly, say, by outgassing from one side, it would never hold a perfect 2D vector. Yet 3I, Atlas did, like a train staying perfectly on track, like a drone flying in a tunnel of glass, like something that knows where the borders are. This geometric flatness told a story, a silent one, a strange one. It whispered of stability in a direction that should be the first to wobble. It pointed to intent in a domain usually ruled by thermal chaos. Imagine a swimmer in the ocean, caught in currents. They flail in 3 dimensions. Up, down, sideways. Now imagine another figure gliding, smooth, staying exactly at sea level, never bobbing, never dipping. That second one is what this object looked like. Not just moving with intent. The implications spiraled outward. If it were natural, what force could keep it confined to a plane? What configuration of mass and rotation, what pattern of venting or surface property could lock an object into a 2-dimensional push? No one had an answer. But the models began to shift. First came the symmetric surface hypothesis, a theory that the object might be coated uniformly, allowing even thermal emissions. But that wouldn't explain directed motion. Even heating causes drift, not push. Then came the tumbling with compensation theory, suggesting that perhaps a combination of rotation and outgassing cancelled out A3 over time. But again, that would produce averages, not a persistent 0. And 3I, Atlas wasn't averaging. It was a choice. The sense of control began to dominate the conversation. This wasn't the kind of control you get from brute force. This was elegant control, the kind you see in engineering, not erosion. No sharp changes, no flinching, just a clean, silent curve through the flatness of the solar system. It began to feel familiar. Familiar not in astronomy, but in aerospace. This was how we guide spacecraft. Keep them within orbital planes. Minimize unnecessary maneuvers. Preserve fuel. Follow the geometry. And the more one looked at the numbers, the more the object resembled a vehicle. Not in shape, not yet, but in behavior. Because behavior reveals intent. And if you strip away every assumption about what a comet should do, then you're left with only one conclusion. This one is doing something we don't see in nature. NASA's own modelling tools began to raise eyebrows. The orbital elements had to be updated daily. New fits to the data kept revealing that the object was staying obediently in its flat lane, like a car hugging a road with perfect traction. People who had spent decades watching gravitational chaos were now looking at a ghost that obeyed geometric laws better than anything built by nature. More metaphors emerged. One astrophysicist in Prague said, "It's like a marble rolling along an invisible table, never falling, never bouncing." A Japanese team proposed the analogy of a coin spinning on its edge across a frictionless sheet, stable, deliberate, and surprisingly quiet. But underneath all the metaphors was one growing unease. This behavior feels familiar because it reflects how we would design movement. That doesn't prove intent, but it starts to smell like it. And in science, patterns that smell artificial deserve to be questioned. Some tried to push back. Coincidence, they said. Maybe the object simply hasn't had time to show a full three-dimensional drift. Maybe it's just an optical illusion projection bias. But weeks passed, and still no drift. The A3 vector remained stubbornly mute. Meanwhile, a 1 and a 2, responsible for motion toward the sun, and within the plane continued to pulse, as if responding to invisible signals. This was not a still object. It was a controlled object, just not in ways we understand. The deeper implication lay not in the numbers themselves, but in the silence between them. Physics always makes room for chaos. But this object seemed to refuse chaos. Its alignment, its flatness, its resistance to vertical movement, none of it was shouted. All of it persisted, and that made it louder than any flare. Astronomy, at its heart, is the study of things we can't touch. We infer intent from movement. We trace stories through orbits. And when an object moves as if by choice, we ask, whose choice? Because the geometry of motion is the fingerprint of behavior. And in this case, the fingerprint felt engineered. When a comet stumbles, it stumbles in 3 dimensions. But this one didn't stumble. It glided. When nature speaks, it does so with noise. But this one moved like a whisper, like a plan unfolding, silently, across the solar system's floor. And those watching it, those who understand how things are supposed to behave, I felt something rare, geometry as a message. Because when nothing breaks the plane, when nothing tilts, jerks or slides, what's left is a kind of stillness, not a lack of motion, but a lack of mistakes. And that, more than anything, was the most unnatural sign of all. Every answer collapses into the same question. How? How does a comet accelerate without a visible tail? How does it steer without jets? Spin without turbulence, and drift without deviation? How does a natural object imitate control? Science thrives on tough questions. And this object offered no easy relief. So the hypotheses came fast, each armed with equations, simulations, and history. Each asking us to believe that this was simply nature, being nature. But one by one they strained, cracked, and quietly failed. The first theory was the oldest in the book. Outgassing. All comets do it. As sunlight warms their surface, trapped ices sublimate, turning from solid to gas, and burst out of porous layers. These jets create small, irregular pushes, not powerful enough to notice at a glance, but across millions of kilometers, they shift orbits, tilt axes, and curl tails. Outgassing is the default answer, the comfortable answer. But it didn't work here. 3I. Atlas was ejecting no visible gas. No coma surrounded it. No tail extended behind it. Even the most sensitive instruments, those designed to detect whisper-faint dust, found nothing. Not even a halo. Still, some argued that maybe the gas was just transparent. Or maybe it was venting asymmetrically, in a way that left no visible mark. So, models were run. They tested carbon monoxide, outgassing a volatile that evaporates farther from the sun than water ice. They tried CO2, methane, ammonia, anything with the energy to cause thrust in the cold vacuum. But all of them demanded a vent geometry that did not match the object's clean, a 3=0 thrust pattern, which led to Theory 2. Symmetric venting. Maybe the surface was speckled with thousands of tiny jets, all balanced, like a spinning lawn sprinkler with perfect holes. The idea was that the net force could push in a single direction, even if no single jet dominated. But that's not how nature behaves. Ice cracks are uneven, surface topography changes. Even in Earth-based comets, venting comes from fractured crevices, not smooth uniformity. The chance of a random object having perfect symmetry and thrust is astronomically small, and if one side received more sunlight, it would dominate. That imbalance would show in A3. Yet it didn't. A 3 stayed at 0, a silence that mocked the idea of chaotic fractal venting. Symmetric thrust without symmetric structure? A contradiction in terms. Still, defenders of the natural tried a third path. Tumbling modulation. Suppose the object was rotating. What if a vent fired briefly on each spin, averaging the thrust over time? The thinking was elegant. Maybe over minutes or hours, the random pushes cancelled out vertically, leaving only in-plane movement. But again, math intervened. For such an average to hold over weeks, the rotation would need to be exactly synchronized with sunlight angles, surface composition, and orbital phase, all while maintaining stable spin, zero nutation, and no visible coma. Too many variables, too much precision, and still, not a single sign of gas. The pressure mounted. So came the next contender, dusty ice erosion. Perhaps 3I Atlas wasn't venting gas, it was shedding mass, a slow release of microdust and vapor from its surface as solar heat cracked its crust. This would be hard to detect, and might explain motion without a coma. But here's the problem. Even low-level dust erosion leaves a mark, especially when viewed from multiple instruments, as was the case here. From the Pan-STARRS array to the Webb Space Telescope, to wide-angle infrared scans, nothing caught so much as a blur of dust. The light curve was clean, too clean, and the object's reflectivity, measured across multiple angles, remained stable, no shifts that would indicate swirling material, no dimming, no flare, no residue. The dust erosion theory left no physical footprint, and science requires footprints. Some theories pushed further. Crystalline phase transitions, internal stress cracking, electrostatic levitation, each more exotic than the last, each hoping that one overlooked physical mechanism might explain a comet that glides instead of flares. And every time, the same question returned. If this is natural, why is it so precise? If it's chaotic, where is the chaos? Natural things leave fingerprints. This object lacks symmetry. Let's talk numbers. The rate of acceleration, non-gravitational, subtle, but steady, would require energy output. A small one, sure, but still measurable. Some kind of exhaust, emission, reflection, decay. Yet even in deep scan wavelengths, thermal, UV, infrared, there was nothing. 3I. Atlas did not warm up, did not flicker, did not spin down, did not fragment. No sign of evolution. The object appeared inert and active, at the same time, a paradox wrapped in a vacuum. And so, the question became less about which natural explanation was true, and more about how many had already failed. It's important to say, failure is not shameful in science. It's the only way progress happens. But when all your models die, what rises in their place isn't an answer. It's a deeper, quieter discomfort. The feeling that maybe you're not asking the right question anymore. Because here's the silent truth. The more we modeled this object like a comet, the more it refused to act like one. And the more we tested our assumptions, the more we discovered just how many of them were made without proof. Why must it be a comet? Because it came from outside? Because it reflects light? Because it moves? These are not identities. They're descriptions, and descriptions can lie. Scientists began to divide into camps. Not believers and skeptics, but modelers and listeners. One group insisted we just hadn't found the right mechanism yet. The other began to wonder if maybe the problem wasn't the explanation. It was the assumption. What if it isn't a comet at all? Not metaphorically, not secretly, but literally. Not a comet. A visitor. An object not shaped by solar birth, but something else. Something with geometry and silence and motion, but none of the messy signatures that scream natural. And yet, no one could say it outright, because to suggest design is to walk into dangerous territory, into speculation, into belief. And science doesn't run on belief. It runs on what can be measured, touched, predicted. But this object couldn't be touched, only watched. And what it showed was perfect disobedience to everything we thought comets must do. So we circled back, again, tried new variables, new material models, new spin simulations. Still, a 3 equals 0. Still, no coma. Still, no jets. Still, the question burned. How? How can something move? Like this, without sound, without heat, without shedding, without noise? How can every explanation fold itself into contradiction? How can silence become a signature? Somewhere between failure and awe, we stopped trying to force an answer and began to listen for what the anomaly itself might be teaching. Not what it is, but what it isn't. Not what causes the push, but what refuses to leave a trail. And in that quiet, a new possibility began to form. Not a conclusion, not even a theory, just a question. What if this is not nature being strange, but something else, acting like nature, on purpose? What if sunlight itself is the pilot, not a force we push against, but a navigator, not background but intention? Because if 3i, Atlas, isn't using gas, or dust, or jets, then perhaps it's using light, not as a signal, not as a metaphor, but literally as an engine. This is where we enter the realm of the light sail, a sail you can't see, propelled not by wind or fuel, but by the gentle, constant push of photons. Every beam of light, no matter how faint, carries momentum. When it hits a reflective surface, it exerts pressure. Minuscule, yes, but persistent. On Earth, we ignore it. But in the void, where there's no friction, no air, no drag, that pressure builds. Over days, over weeks, over millions of kilometers. Sunlight becomes thrust. This isn't science fiction. In fact, it's one of the oldest dreams in space engineering. Johannes Kepler imagined it in the 1600s. Carl Sagan championed it in the 1970 seconds. And in the 21st century, we made it real. The Icaros mission by Japan, the light sail projects by the Planetary Society, experiments using mylar sheets thinner than a human hair, catching the sun and gliding. No fuel, no plume, just a reflection, like a feather drifting upward in a windless sky. Now look at 3i, Atlas again. It moves without thrust. It reflects sunlight with unusual efficiency. Its motion aligns precisely with the orbital plane, where light pressure acts strongest, and its acceleration matches what we'd expect if its geometry were flat, smooth, like a sail. Could this be one? Let's review the math. Radiation pressure from sunlight at 1 AU distance from Earth to Sun is about AU, 4.6 micronewtons per square meter. That's tiny, but over weeks, if your object is wide and light, the push adds up. To match 3i, Atlas's observed motion, the object would need asterisk, a very low mass to area ratio, thin and large. Asterisk A, surface capable of high reflectivity. Asterisk, stability of orientation, so the thrust doesn't wobble. And here's the catch. This is exactly what some scientists proposed for Oumuamua. Remember Oumuamua? The first interstellar object ever detected, 2017. It moved strangely, accelerated slightly, had no visible tail or coma, reflected light, oddly its brightness changed by a factor of 10, and the mystery drove researchers toward the same possibility. A light sail, a flat, thin object artificial in design, catching sunlight as its propulsion source. That idea came from Avi Loeb, a Harvard astrophysicist. It sparked debate, criticism, and fascination, but no one disproved it. Now, years later, 3i, Atlas, follows the same pattern, but with even more symmetry, even more silence, even more precision. It's as if we're seeing the same message, written more clearly the second time. But it gets stranger, because if light is the engine, then reflection is the exhaust. And 3i, Atlas, reflects light too well. Multiple spectroscopic studies noted its high albedo, the measure of reflectivity, higher than expected for a rock or dust. more like polished metal, and its lack of spectral features no clear signature of water, carbon, or silicates puzzled researchers. It wasn't just quiet, it was smooth, unnaturally smooth, which is exactly what you'd expect from a sail, not a stone. Critics pushed back. They argued that 3I Atlas could still be a comet with a thin crust. That reflectivity doesn't prove anything. That maybe it's tumbling just right. But here's the counter-argument. It doesn't need to prove anything. It just needs to match the light sail hypothesis better than any natural alternative. And it does. No model of outgassing fits. No venting pattern explains. A 3 equals 0. No known natural material reflects this way without shedding. But a sail? It fits. It doesn't require a tail. It doesn't require heat. It explains the movement. It explains the silence. Let's take a step back. If 3I Atlas is a light sail, then someone built it. Or something did. That's not a leap. That's a logical consequence. Because sails don't form from impact. They don't crystallize. They don't break off from planets. They are manufactured. They are decisions, not accidents. So the moment we take the sail idea seriously, we begin to face a new kind of question. Not, what is it made of? But, why is it here? Where is it going? And who sent it? Of course, science proceeds with caution. Most papers discussing 3I Atlas still list it as a comet-like interstellar object. They include footnotes about light pressure. They mention previous analogues, like Oumuamua, but they stop short of calling it artificial. Why? Because the implications are enormous. Because careers hang on neutrality. Because we fear being wrong, especially in public. And because the burden of proof for design is heavier than for chaos. But when the data tilts toward elegance, what do we owe curiosity? What do we owe the silence? Let's suppose it is a light sail. What would that mean? It means that motion is no longer a question. It's the message. The object is telling us not with signals or beacons, but with geometry. Precision isn't just a feature. It's the clue. And reflection isn't a byproduct. It's the engine, which changes everything. Because now, the story isn't about strangeness. It's about engineering. It's about design. It's about noticing what's been traveling past us, all this time, unread. And perhaps, most curiously, it suggests a kind of humility, that in a universe so vast, we might not be waiting for contact. We might be observing an older message, already passing through, a piece of knowledge, not aimed at us directly, but drifting in patterns we are only now beginning to recognize. Not because we're finally ready, but because it was always there. So maybe sunlight is the pilot, and the stars are the map, and we, the observers, are the students. Not of aliens, not of invaders, but of navigation. This is not proof. This is a possibility. But that possibility now stands beside us, reflecting light, riding curves, and whispering with every silent mathematical motion, I was made to move this way. Rocks don't steer. This one seems to. And that single contradiction between inert matter and behavior changes the nature of everything we're observing. Because if 3I Atlas isn't simply moving, but maneuvering, then we are no longer dealing with an object. We are dealing with a decision. Let's start with the concept of propulsion. In all known natural celestial mechanics, motion happens because of three things. Asterisk. Inertia. Asterisk. Gravity. Asterisk. Or chaotic outgassing in the case of comets. But 3I Atlas exhibits something else. A pattern that matches the geometry of intent. Its path doesn't just drift. It corrects. Its thrust isn't random. It's consistently in plane. Its motion appears. Governed. But governed by what? We don't see gas jets. We don't detect heat. We don't measure torque. And yet, its acceleration vectors shift in a way that suggests adjustment. The kind of adjustment you'd expect if something was trying to maintain orientation, or follow a course, or correct against perturbations from solar wind and gravitational tides. And that kind of adjustment is typically the realm of control. NASA's JPL Horizons data showed something unusual in the weeks after perihelion. A slight course correction, not large enough to draw headlines, but sharp enough to raise eyebrows in orbital mechanics circles. It was as if the object was holding its line, a subtle compensation. Not random drift, but retention of the trajectory. This is what prompted some physicists to quietly raise a question they don't raise lightly. Is there agency in the data? Not a science fiction agency, not alien as in cinema, but agency as inferred from motion, from course discipline, from resistance to entropy, because in nature, entropy wins. But here, something resists it. Now, we should be cautious. Words like control and intent carry connotations. They imply will, and that opens doors we might not be ready to walk through. So, let's reframe. Let's speak only in terms of anomalous behavior. Let's say, this object behaves like it is preserving a course. This object demonstrates thrust without spin. This object sustains a path in spite of solar irregularities. These statements are empirical. They're measurable, and they contradict what we expect from rock and ice. If you launched a sail into space, a simple, thin sheet meant to ride the sun, you'd expect it to drift, to tumble, to deviate with the slightest pressure change. Unless it had a way to correct, a way to steer, which raises an elegant, uncomfortable question. How much course correction does it take to prove intent? What's the threshold where physics becomes choice? The answer may not lie in magnitude, but in consistency. A rock can behave oddly. Once. A comet can have a weird thrust. Sometimes. But a course held across tens of millions of kilometers, with no coma, no plume, no venting, that's not persistence by accident. That's persistence by pattern. And in science, pattern is always the fingerprint of something else. Now let's talk about the maneuver. Not the dramatic kind, like rocket engines firing, but the quiet kind, a shift so small you only see it in the math. This is what makes 3I, Atlas's movement, so haunting. It doesn't zigzag. It doesn't wobble. It aligns. Its orbital inclination stays tight to the solar plane. Its non-gravitational acceleration remains aligned with its velocity vector. Its a 3-parameter vertical deviation is still effectively zero. That's precision. Not just unusual, but disciplined. Some suggest it could be a natural flat object catching sunlight perfectly, a coincidence of shape and orientation. But the odds of that? Astronomical. More importantly, the longer it holds that shape and plane, the more improbable it becomes. In a dynamic solar environment, buffeted by wind, radiation, and planetary pulls, stability decays. But this object remains stable, which brings us back to the uncomfortable implication: self-stabilization. What does that mean? Well, if an object maintains its thrust direction and course orientation across long distances, without any visible cause, it either 1. Got unreasonably lucky, or 2. Has some form of internal compensation, active or passive. If active, it's correcting. If passive, it was built to self-correct. Either way, we are no longer in the realm of unshaped rock. We are in the presence of design. Let's entertain a simple analogy. Imagine a canoe drifting on a calm lake. If a breeze blows, the canoe shifts. Now imagine the canoe corrects just slightly to stay pointed toward the far shore. Once might be a chance, twice might be a wind pattern, but a dozen corrections? You look inside the canoe and begin to expect a hand on the paddle. That's where we are with 3I, Atlas. We're seeing tiny paddles, invisible, mathematical ones. Not on the surface, but in the numbers. The whisper of intent isn't a sound. It's a pattern in silence. We don't hear it. We measure it. In the absence of noise, we get motion. In the absence of explanation, we get discipline. In the absence of cause, we get correlation again and again, which leads us to a possibility modern science often avoids, meaning embedded in movement. Some will call it a stretch, and perhaps it is, but science stretches best when data leads. And here, the data doesn't just lead. It points towards something keeping course, towards something pushing back, towards something deciding. That doesn't mean pilot, or machine, or even intelligence as we understand it, but it does mean non-randomness. And in a universe dominated by entropy, non-randomness is a kind of voice, a whisper of intent. The sun flared, the comet moved, one heartbeat apart, two events, one cosmic rhythm, and no one could prove they were connected. But no one could prove they weren't. On the 2nd of November 2025, just as 3I, Atlas, began to exhibit a fresh acceleration vector, the sun released one of its most powerful flares in years, an X3. 7-class coronal mass ejection, or CME, surged outward, sending plasma and electromagnetic waves rippling across the heliosphere. Roughly 13 minutes later, 3I Atlas altered its velocity, a tiny, quiet nudge, too subtle for the naked eye, but unmistakable in the data. It was almost as if the comet had felt the sun breathe and moved in reply. Of course, it could be a coincidence. After all, the sun is always active, but solar scientists raised their eyebrows, because this flare wasn't just any outburst. It was part of a cluster, an unusual sequence of high-energy events, erupting over the span of just 3 days. More than a dozen observatories logged it. NASA and ESA both issued geomagnetic storm alerts. Auroras lit up the skies as far south as Colorado, and in the middle of it all, this interstellar traveler, silent, tailless, shifted course. Here's where the story deepens. The solar flare originated from AR 3548, a sunspot region that had shown signs of magnetic complexity for weeks, but its timing precisely within a 90-minute window of the JPL Horizon's data update for 3I Atlas felt too sharp to ignore. The flare's energy hit Earth's magnetosphere, but it also spread outward, touching the orbit where Atlas was projected to cross. The question arose, was this interaction mechanical or informational? Let's unpack that. In classical physics, a CME can't directly push a comet with much force. The solar wind's pressure is minuscule, especially over interplanetary distances. But what if the object in question wasn't passive? What if it responded not to force, but to light conditions, to electromagnetic changes, to the sun's heartbeat? That's when the metaphor shifted. No longer was the sun simply a star. It became a drum. And 3I Atlas, perhaps a listener. Astronomer Stephen Burns, speaking at a conference in Tokyo that same month, coined a term that would ripple through online science communities: solar echo synchrony. It described the appearance of a small body echoing or mirroring solar events, with a delay so small it suggested feedback, not mere reaction. Burns emphasized he wasn't claiming alien influence, only that we might be watching a dialogue, and had no framework yet to interpret the language. He pointed to 3 more incidents. Asterisk. November 4, sunspot AR 3550 flares, minor vector adjustment logged on 3I Atlas. Asterisk. November 6. Sudden drop in solar wind speed 3I. Asterisk. November 9. Micro CME, anomalous brightening of the object's reflectivity spectrum. Not proof, but not noise either. Let's pause on that word. Reflectivity. One of the more curious observations came from an amateur telescope array in Chile. Using polarized filters, they noted a brief spike in photonic bounce, as if the object's surface had reoriented or smoothed. This happened hours after the CME. Now, a natural fragment of ice or rock shouldn't respond like that. But a sail, or a panel, or a thin, mirrored surface, that would make perfect sense. It would catch the light. It would reflect and shift just as 3I Atlas did. All of this adds up to a pattern, not in space, but in time. When you lay the solar activity log against 3I Atlas's motion data, you don't get a perfect overlay, but you get rhythm. Not every flare triggers a motion, not every motion follows a flare, but the correlation is above random. And for scientists used to chaos, that's where the mystery begins. So how could such a correlation arise? There are 3 possible paths. 1. Coincidence. Solar activity is constant, and 3I Atlas just happened to move at the same time. This is the simplest explanation and the least satisfying. 2. Passive reaction. The object has properties, like a light sail, that make it sensitive to solar changes. It's not alive. It's not aware, but it responds to light, heat, or radiation predictably. 3. Active synchronization. This is the boldest theory. It suggests the object is monitoring the sun and modulating its movement to stay in harmony. Not just pushed, but dancing. The implications of synchronization are staggering, because they suggest not just propulsion, but awareness of the environment. That doesn't mean consciousness. It could be algorithmic. It could be engineered. It could even be emergent behavior from materials we don't yet understand. But it feels deliberate, like a violin string vibrating in resonance with a distant orchestra. The sun plays. The object answers. Not always, but enough. There's a philosophical weight to this too. For centuries, the sun has been the anchor of our world. It sets the time. It powers life. It marks seasons and days and orbits. But what if it also signals, not in language, but in light, not in code, but in a flare? What if the sun has always been sending messages, and only now are we watching closely enough to suspect someone's receiving them? This brings us to the most delicate part of the theory, because if 3I, Atlas, is interacting with the sun, even subtly, then we are no longer observing a comet. We're observing a participant in the solar system, not just passing through, but synchronized, not random, but responsive, not inert, but perhaps attuned to the great metronome of this star. So, what do we call this? Not proof, not revelation, not encounter, just timing, curious timing, too elegant to ignore, too fragile to declare. The sun flared, the comet moved, one heartbeat apart, and in that sliver of time, the universe may have whispered that we are not the only ones, listening to the music. When the heavens tremble, Earth remembers, not immediately, not with fanfare, but with a pressure that builds quietly, in stone, in crust, in magnetic silence. The warning came not from myth, but from measurement. In late 2025, solar physicist Stephen Burns stood before a room of geophysicists and seismologists in Geneva and posed a question no one expected. What if the next big earthquake doesn't start from below? Silence. Then he showed the data. Burns presented a chart correlating geomagnetic disturbances and tectonic events over the last 3 solar cycles. No one had seen it laid out quite like this before. Spikes in solar output, especially major X-class flares and CMEs, seemed to cluster within a 3 to 5 day window of increased deepquake activity in regions with known fault lines. Coincidence? Maybe. But the model had a name. He called it the Big Wave. The Big Wave wasn't a single explosion. It wasn't a tsunami or a flare or a quake. It was a resonance cascade, a build-up of interconnected energies, cosmic, magnetic, tectonic, reaching across scales we don't usually place side by side. Imagine this. 1. The sun flares. 2. The solar wind hits Earth's magnetosphere. 3. The geomagnetic field flexes, subtly but globally. 4. Deep beneath the crust, zones already under tectonic stress absorb that disturbance like a tuning fork catching vibration. 5. Not all faults respond, but some shift. Not directly from force, but from resonance. This isn't pseudoscience. Burns was careful to say that no solar storm has the brute strength to cause an earthquake. But what if that's not how influence works? What if it's not about pushing, but about tipping? Just as a singer's voice can shatter glass at the right frequency, what if the sun's pulse can nudge the Earth's own frequencies into motion? Here's where 3I, Atlas, returns. Because Burns wasn't just tracking solar activity and seismic shifts. He was tracking the presence of outliers, things that shouldn't be in the mix, but were. And Atlas was the biggest outlier of all. In the week following the X3, 7 flare of November 2, 3 seismic anomalies occurred. Asterisk, a magnitude 6.1 quake off the coast of Peru with no preceding tectonic stress indicators. Asterisk, unusual harmonic tremors under Mount Etna, as if something was resonating deep inside. Asterisk, a 4, 9 microquake swarm beneath the Indian Ocean, in a region considered geologically quiet for decades. All 3 happened during periods of elevated geomagnetic turbulence that matched the timing of 3I, Atlas's anomalous course shifts. The implication wasn't direct causality. Burns made that clear, but it felt like a signal, a pattern that defied standard models, but whispered of hidden links, as if the Earth and the stars were sharing a rhythm. We hadn't tuned in yet. This wasn't entirely new. Historical studies had flirted with the idea that solar maxima coincided with increased volcanic and seismic activity. What was new was the precision of the data, and the synchronization with an interstellar object, a comet or something else, arriving just as the Sun and Earth began to speak more loudly. Let's zoom in on the theory. Burns described Earth's crust as a pressure system in waiting. Most of the time, it manages stress like a sponge, but every so often, a subtle vibration or energetic fluctuation pushes it beyond threshold. This might not trigger a quake immediately, but it could rearrange internal loads, change stress vectors, and reset the countdown clock on events already written into the planet's geology. Now, layer in a mysterious object, gliding silently, without a coma, timing its movements with solar outbursts. And you don't just have a puzzle. You have a question no one wants to ask. What if 3i, Atlas, isn't just observing? What if it's participating? Could it be mapping solar-Earth interactions, testing resonance windows, measuring fault line reactivity, or more chillingly, recording how life responds to planetary instability? We don't know. We can't know. But what we can do is watch what happens next. In Burns's final slide, he showed a projected window, November 29, the 3rd of December 2025, marked in red, an alignment between solar flare probability, geomagnetic flux, and Atlas's next perihelion arc. He didn't predict disaster, but he predicted anomalies, not just in the sky, but in the ground beneath our feet. Critics called it speculative, a leap too far, correlation, not causation. But others, especially within quiet corners of astrophysics and geology, paid close attention, because Burns wasn't selling fear. He was tracing patterns that were repeating, patterns that felt too timely to ignore. And once you see the wave, rippling between worlds, you can't unsee it. The phrase caught on online, not solar storm, not comet alert, but something older, deeper. The big wave is coming, not just light, not just heat, but a frequency that touches everything, from stars to stone to cells. And so we're left with this unsettling possibility. That is when the heavens tremble. Earth doesn't just witness, it remembers. Its rocks remember. Its oceans remember. Its fault lines remember. And sometimes that memory is awakened, not by time, but by tone. A tone carried by light, etched by gravity, and perhaps traced by something far older, far wiser, and far more intentional than we've dared to imagine. Science wants truth, but careers prefer safety. And nowhere does that contradiction roar louder than when something like 3i, Atlas, appears. From the outside, science feels clean. Equations, telescopes, data, facts and figures under neutral light. But inside the machine, inside the meetings, the peer review boards, the email threads, truth often takes a backseat to survival. The first scientist to submit a paper proposing controlled propulsion for Atlas, it didn't even get a rejection. They got silence. No reviewer. No comments. No entry into the system. It vanished. Later, they found out unofficially that the editor had flagged it as unfounded speculation and withheld it to protect the journal's reputation. This wasn't censorship. It was institutional caution, 1,000 invisible levers pulled by people who still believed in science, but not in career suicide. The phrase used in private was always the same. We can't afford to look ridiculous. Not after what happened with Oumuamua, not after the media frenzy, the alien headlines, the ridicule. Many astronomers had their funding questioned after even entertaining non-natural possibilities in 2017. So now they whisper. Now they watch. Now they wait for someone else to go first. But the data was moving faster than the politics. New independent observatories were submitting readings of Atlas's motion vectors. The thrust remained confined to the orbital plane. The acceleration remained non-random. And every attempt to explain it with standard cometary physics kept hitting the same brick wall. Where is the coma? Where is the gas? Where is the source? A leaked internal memo from a mid-sized European institute read, "There is no mechanism in our current thermodynamic modelling that can produce this acceleration profile without violating Newtonian assumptions. We do not recommend publication at this time." They didn't mean the data was wrong. They meant, we don't know how to talk about this yet. So, debate went sideways. Not about Atlas itself, but about how science should deal with it. Should we speak plainly and risk sounding like fringe theorists? Should we say nothing and appear dishonest? Should we reframe the anomaly to keep it inside the comfort zone? The word they landed on reluctantly was unexplained. That's what appeared in official briefings, updates, bulletins. 3i. Atlas displays unexplained non-gravitational acceleration, but even that word became radioactive. Inside one NASA task force, members argued for hours over whether unexplained implied intelligence. One senior researcher suggested replacing it with uncharacterized. Another countered, that's the same thing with more syllables. we're not fooling anyone. A third added, it doesn't matter. People already think it's a spaceship. Silence. Then someone laughed, not because it was funny, but because it wasn't. The deeper truth was this: science thrives on mystery, but careers don't. A scientist who admits, we don't know, risks becoming the subject of internet memes, YouTube theories, or worst of all, a funding casualty. So they play it safe. They hedge. They wait for more data. They stall for consensus, even when the sky is shouting. In a late-night forum thread on a private Slack channel, a young physicist from Japan typed, "I became a scientist to understand the universe, but now I feel like I'm being asked to ignore it, until the story is easier to explain." Another replied, "I think the universe is asking better questions than we are. This is not a takedown of the scientific process. The rigor of that process, the demand for replication, skepticism, peer review, is what keeps humanity grounded in truth. But even the best systems creak when faced with something too big to categorize. There was a time when the idea of continental drift was considered laughable, when meteorites were dismissed as superstition, when black holes were mathematical curiosities, not real objects. What made those theories respectable wasn't just time, it was a risk. Someone dared to say, I think this might be real, even if I lose everything by saying it. Now, we stand at a similar edge, looking at a pattern of motion with no visible cause, a trajectory that bends expectation, a traveller that defies classification. And the question is not just what 3i Atlas is. The question is, do we still have the courage to ask out loud? Because hidden behind the debates and memos and committee votes is a very human fear, not of aliens, not of collapse, but of being wrong in public, of publishing the thing that gets you laughed off stage, of being remembered for the paper that no one would touch, of being first and alone. But science needs that kind of loneliness, because only from that edge do the next discoveries emerge. Every great leap began with one person hearing the noise of debate and saying, no, I'm going to follow the anomaly. In the case of Atlas, there were a few independent researchers, citizen scientists, a professor in a small university who gave up a tenure track to publish a self-funded paper titled Angular Conformity and Thrust Precision in Interstellar Object 3, I Atlas. It went unnoticed for weeks. Then someone translated it into Spanish. Then someone animated it for YouTube. Then the conversation changed. Because while institutions stall, narratives move. And once the public starts seeing patterns, even the safest theories begin to shift. Because science, in the end, does not belong to journals. It belongs to curiosity. And curiosity, it never retires. It doesn't care about tenure. It isn't afraid to look foolish. It just wants to know, even when knowing is uncomfortable, even when knowing means breaking the frame. We built around what we thought was real. So, maybe the next chapter of science doesn't come from a press release. Maybe it comes from an amateur in Chile, or a thread in Portuguese, or a diagram on Reddit that dares to ask a forbidden question. Maybe it comes from someone who hears the noise of debate and listens instead for the whisper underneath. The whisper that says, don't protect the truth, pursue it. Sometimes, what's missing in the data speaks louder than what's found. This is the paradox at the heart of 3i Atlas. Because for all the high-resolution readings, the orbital modelling, the elegant curves from NASA's JPL Horizons database, something always felt incomplete. The data was public. Sort of. JPL Horizons, the tracking tool that logs millions of celestial bodies, did publish Atlas's orbital elements. They even logged non-gravitational parameters, a 1 and a 2 active, a 3 0. A 1 controls the push away from the Sunday. A 2 adjusts the swing along the orbital path. A 3, the vertical axis was dead flat. That alone was weird. But it's not what raised eyebrows. What did this? The frequency of updates began to slow down, at precisely the moment Atlas's behavior became most erratic. Before mid-October 2025, trajectory updates came daily, sometimes hourly. A new point, a new model, a new curve. Then, as the object entered its anomalous phase near the Sun, with no jet, no coma, no visible propulsion, the model froze. For 3 days, then 5, then 8. Astronomers watching the object in real time, especially amateur observers, began asking questions on public forums. Why hasn't Horizons updated Atlas since perihelion? Has anyone seen the October 2931 data? There were no answers, no press release, no error message, just silence. Eventually, a single new trajectory point appeared, but this one came with a note: data smoothing, applied due to observational inconsistencies. What does that mean? No one could agree. Some said it was routine, just normal error correction. Others pointed out that no such note had accompanied other interstellar objects, even when the data was sparse. Then came the whistle. Not a whistleblower, a glitch. One line of server-side metadata in a public mirror of the JPL feed contained a timestamp referencing an unpublished observational report from the Infrared Telescope Facility, IRTF, in Hawaii. It was dated the 30th of October 2025, right in the blackout window. That file has never been released. What's more troubling is how common this pattern is. In multiple past cases, Oumuamua, 2I, Borisov, now 3I Atlas, data gaps appear during critical observation windows, and always the justification is the same: observational inconsistencies. But what if inconsistency isn't a bug? What if it's a flag? A marker that something doesn't fit within the expected system? Let's talk about trust. Science rests on data. Data rests on transparency. But transparency in space science is not as absolute as it seems, not because of malice, but because of management. Large-scale observatories, especially those affiliated with military or dual-use agencies, don't always push real-time data to public streams. This is especially true for near-Earth observations, infrared imaging, and electromagnetic anomalies. A lot of this has to do with national security, satellite interference, and avoiding false alarms. But the consequence is this: gaps form, and those gaps, in the context of mystery, become breeding grounds for speculation. In the case of Atlas, one particular discrepancy caught attention: the radar cross-section. Initial estimates suggested a diffuse body, like a typical comet nucleus, but a separate team, using low-frequency radar, logged a stronger return than expected, as if the object's surface was smoother or more reflective than ice and dust would allow. This result was never included in the official composite reports. Why? The team that recorded the anomalous reflection worked under contract with an aerospace research branch, affiliated with a national defense agency. Their data was proprietary. It's not 50. The public only learned of it because a student intern included the reflection coefficient in a conference abstract before being told to retract it. There's no conspiracy here, no hidden aliens, no cover-up in the cinematic sense. But what there is selectivity. In science, data is not just recorded, it's curated, filtered, framed, especially when it challenges core assumptions, especially when releasing it unfiltered. It would invite questions no one is ready to answer. Even the models, those elegant JPL arcs, are not pure data. They're inference engines. They extrapolate based on observed points, but also make assumptions about forces acting on the body. For most comets, those assumptions are valid, but for Atlas, they become distortions. The models continue even when the physics stops making sense. This isn't just a technical issue, it's a psychological one. There's a kind of comfort in thinking the data is complete, clean, and consistent. We like our mysteries to have neat boundaries, a box to hold the strange, a timeline to contain it. But Atlas slips through those boundaries, not violently, quietly, in what's missing, what's smoothed over, what's delayed, what's not yet ready for release. One private email between observatory teams read, "There's something elegant and maddening about this object. The more we try to look directly at it, the more it moves sideways through the narrative. Maybe that's the truth at the core of 3I, Atlas. Not that it's hiding, but that our systems are still too rigid to hold something this nuanced." And so, behind closed doors, the conversation continues. Draft reports, unpublished results, internal models with parameters that cannot yet be justified in public. And outside those doors, a growing audience watches, not for answers, but for inconsistencies. Because in this story, those inconsistencies are the trail. The places where the data falters might be the places where truth is trying to get in. We don't know what's in the IRTF file from October 30. We don't know why the radar team stopped talking. We don't know what A3 equals 0 really means when the motion doesn't match the math, but we do know this. Curiosity doesn't wait for permission. It just keeps pulling, even when the doors are closed, even when the silence is louder than the signal. Especially then, when machines learn curiosity, science changes forever, not because they replace us, but because they see what we cannot. This is the story of a machine that noticed 3I, Atlas, before most humans did, and how it's just the beginning. On the 23rd of October 2025, 5 days before Atlas made its closest approach to the Sun, a quiet alert pinged inside the servers of the LSST, the Legacy Survey of Space and Time, a billion-dollar sky mapping project. Atop Cerro Pachon in Chile, it wasn't a human who noticed it. It was an AI pipeline named Foresight. Its job was simple: compare millions of real-time images against historical patterns, flag what doesn't fit. But that night, Foresight did something its developers didn't expect. It flagged not an image, but an absence. The region of sky Atlas passed through should have shown a brightening tail, but frame after frame showed none. No coma, no jet, just a pinpoint star-like glow, moving faster than any known comet. The AI didn't know what it meant. It didn't need to. It simply registered an anomaly in motion, brightness profile, and reflectivity curve, and escalated the alert. Human teams reviewed the frames the next morning. Some dismissed it as an imaging error. Others weren't so sure. By the time the debate began, Atlas had already passed perihelion, and the window was closing. This is what machines do best. They never get bored. They never look away. They never bring assumptions. They don't know what comets should do. They just know what they have always done. And when something doesn't, they raise the flag. The implications are staggering. In past decades, a new interstellar object might have passed unnoticed for months, or been misclassified entirely. But with machines watching, the sky becomes a living ledger. Every deviation logged, every silence is recorded. It's no longer about spotting something weird. It's about teaching algorithms to recognize different. The telescope isn't what's revolutionary. It's the observer. Because now, the observer isn't a person behind a lens. It's a neural network trained on terabytes of sky. Take this example. In August 2025, Foresight flagged a known comet for a subtle pre-perihelion shimmer that no human had ever noticed. The cause? A resonant wobble in brightness, consistent with internal tumbling. A few weeks later, it broke apart, just as the machine had predicted. These systems aren't just reactive anymore. They're predictive. They study statistical ghosts in the noise we overlook. Tiny oscillations, hidden harmonics, brightness curves shaped not by light, but by mass and orientation. In the case of Atlas, Foresight picked up something strange, a flat reflectivity curve, even as the angle of sunlight changed, which shouldn't happen, unless the surface was uniform or engineered. But here's the deeper shift. Machines are no longer just tools of discovery. They are becoming collaborators in wonder. We feed them rules. They return exceptions. We show them symmetry. They return fractures. We model possibility. They find what violates it. And in that dance, something new is born. A second system. An AI anomaly sorter, developed in Japan, also flagged Atlas. Around the same time, it did so not based on brightness, but trajectory acceleration profiles. It plotted the object's course against known solar and gravitational forces and found that, statistically, less than 0.01% of all known objects shared its specific acceleration vector, with zero vertical deviation, a 3 equals 0. It labeled the object probable non-natural trajectory, not as a declaration, just a statistical outcome. But sometimes, that's all it takes to crack open a paradigm. There's another angle here. AI can now model alternate histories. Given what we know about comets, a machine can run millions of what-if scenarios and compare each to the actual path of 3I, Atlas. In thousands of those simulations, even the wildest combinations of outgassing, dust venting, thermal lag, none of them matched the flat plane acceleration and solar synchronized boost. Humans might argue over interpretation, but machines deal in match rates. And the match rate for natural comet behavior? Low, extremely low, which raises an idea too fragile for many to say aloud. What if our search for extraterrestrial intelligence is happening in reverse, not listening to radio, not chasing signals, but noticing that an object already behaves like it's watching us? Here's where things get poetic. What happens when machines begin detecting intent, not consciousness, but pattern, precision, deviation wrapped in discipline? If our own tools start noticing design in the stars, how long before we believe them? There's a quiet revolution happening in astronomy. It's not in the telescopes, not in the data. It's in how we see, not with eyes, but with learning, with the strange, tireless curiosity of the very systems we built to be neutral, and who now return to us. Something that feels anything but. Machines logged 3I, Atlas, before most of us understood what it meant. It may not be the last, because if the sky is a message, it makes sense that we'd need help learning to read it. And if one day something blinks back, maybe it won't be a scientist who sees it first. Maybe it'll be a machine that's learned how to wonder. The sun breathes fire, and everything in its reach listens. It is not silent. It is not still. It is not distant. It is alive with electric breath. And every comet, every rock, every ship of light or dust, they must move through it. When 3I, Atlas, crossed into the heliosphere, it entered more than just sunlight. It entered a sea of forces we still only half understand. Coronal mass ejections, solar wind, plasma rivers, magnetic fields that stretch and snap like elastic bands. The sun is not just a light bulb. It is a cosmic engine, spinning and pulsing, sending invisible waves through every inch of space it touches. And sometimes those waves change everything. On the 29th of October 2025, as Atlas approached perihelion, the sun released an X-3, 7-class CME, one of the most powerful in recorded history. It blasted plasma at nearly 3,000 kilometers per second. At first, it seemed unrelated. Comets pass the sun all the time. CMEs erupt all the time. Coincidence, perhaps, but the timing was eerie. Within 40 minutes of the CME, 3I, Atlas, began to change velocity. Not randomly, not subtly, decisively. Here's what we know. CMEs carry not just light, but charged particles and magnetic energy. They interact with objects in space, depending on material, shape, and mass. But comets by nature should react unpredictably. They spin, they outgas, they tumble. Yet, Atlas did something else. It accelerated in a straight, planar direction with no visible thrust and no coma. This has led some scientists to explore an old but powerful idea: radiation pressure, a force created not by heat, but by photons, by light itself. Photons have no mass, but they carry momentum. When they strike a surface, especially a wide flat one, they can push, very gently, very consistently, and very silently. It's how light sails work. Could Atlas have responded to the sun's breath as if it were built to do exactly that? As if it were expected? Solar events, and used them. There's precedent. NASA's Icaros mission used a 14-meter sail to harness sunlight for continuous propulsion. It had no engine, no fuel, just a thin membrane, and the sun's gentle push. Now imagine something far older, far larger, drifting through space, for millennia, waiting for flares, like a surfer waits for waves. That's one hypothesis. But there's more than just photons in solar wind. There are plasma bursts, capable of generating an electrical charge when they pass through or around an object. If Atlas has any internal structure, any conductive material, it could theoretically convert that passing plasma into motion. Think of it like this. The sun sneezes. Atlas shifts, not because of gas, but because of the current, not because of randomness, but because it was listening. Some theorists even propose a reactive magnetic signature, a way for a craft to align its path using the interplanetary magnetic field, like a sailor adjusts to the wind. This wouldn't require a mission, just adaptation, just intelligence, or design. But there's another layer still: resonance. The sun's radiation comes in pulses, some short and sharp, others are long and slow. These pulses have rhythms, Frequencies. Some researchers believe that certain materials or geometries can be tuned to respond more strongly to specific solar harmonics, like a string vibrating only when the right note is played. Was Atlas vibrating in time with the sun? None of this proves intention, but none of it feels accidental either, because the moment the sun roared, Atlas moved, and it didn't just move, it glided. No spin, no spiral, no loss of momentum, just a clean, silent deviation, like a leaf catching wind from a breath it was waiting for. And that brings us to the biggest question of all. What is space really? Not the emptiness we once thought, but a field, a medium, a plasma-rich ocean where energy flows and everything responds. The sun doesn't just shine, it plays in the space around it, and anything tuned to its song, natural or not, might one day sing back. To understand Atlas, we must understand the Sunday, not as a furnace, but as a conductor, and perhaps one day we'll realize that the real search for extraterrestrial intelligence begins not with listening for voices, but with watching who already dances to the sun's electric breath. Even dust carries memory, and sometimes momentum. This is not poetry. It's what the spacecraft Hayabusa 2 and OSIRIS-REx quietly taught us. Sometimes, what moves is not what we see. Sometimes, motion comes not from violence, but from the slow exhale of a porous stone, warmed by time. Let's go back to Earth. Before we stare at stars, for centuries we imagined comets as icy rocks, hard, sealed, volatile only when forced. But nature is gentler and far more intricate. In 2020, when Japan's Hayabusa 2 returned with samples from Ryugu, it brought home something strange, dust that didn't behave like dust. These particles, more like sponge than stone, were riddled with microcavities, interior voids, networks of invisible passageways. And then NASA's OSIRIS-REx from the asteroid Bennu confirmed it. These space rocks aren't rocks. They're fractal labyrinths of dust, held together by forces so delicate that sunlight alone might be enough to move them. This changes everything, because when sunlight hits such porous material, heat doesn't just reflect, it seeps in, lingers, travels, and as it does, gases trapped deep inside, even in tiny amounts, can release gradually, silently, without ever forming a visible tail. No fireworks, no coma, no drama, just a breath, just motion. This is called invisible outgassing, not a jet, not a spray, but microventing, whispers of force, from structures too delicate for our telescopes to see. Hayabusa showed that Ryugu's particles, he could do exactly this. So could Bennu's. So could 3I, Atlas. Here lies the humble bridge between the mysterious and the explainable. Maybe Atlas doesn't need alien engineering. Maybe it's just dust that knows how to remember the Sunday. Because here's the truth. Motion doesn't always need fire. It only needs an imbalance. When one side heats faster than another, even a microscopic release of gas can impart thrust, especially if the object is light and porous and built for space. Scientists call this the Yorp effect, a torque from sunlight that can change an asteroid's spin over long timescales. Now imagine that, but in 3 dimensions, with gas involved, on an object we've never seen up close. Suddenly, the clean, silent acceleration of Atlas doesn't feel so alien, just subtle, just overlooked, just dust, doing what dust does best, reacting slowly, but surely, to the hand that warms it. And yet, the mystery doesn't vanish. It deepens, because even if Atlas is natural, if it's just a porous body, venting silently, then why is it so consistent? Why does its thrust stay perfectly aligned with the orbital plane with no A3 component? Why does it accelerate only at moments of solar disturbance? And why does it rectly seem to adjust, not just react? This is where probability comes in. Hayabusa and OSIRIS-REx found a wide variety of material responses. Most tumble, most outgas asymmetrically, most behave chaotically. To find one that behaves with this much symmetry, with this much stability, by chance, is rare. not impossible, but rare. And in science, the rare must be tested just as deeply as the fantastical. There's another layer. If Atlas really is porous, and its venting is invisible, why can't we detect any emissions? Not even trace spectra? With Ryugu and Bennu, we had close-up sensors. With Atlas, we only have telescopes. It's like trying to watch a candle's smoke from 100 million miles away. So we sit between two truths. One is extraordinary, that Atlas is an artificial probe using solar energy with precision. The other is quietly profound, that the universe, in its subtlety, can create objects so finely tuned they feel designed. Either way, we are confronting something new, and perhaps that's the real gift of missions like Hayabusa 2 and OSIRIS-REx. Not just data, but perspective. They remind us that the universe doesn't shout, it whispers, and if we only listen for roars and flames, we'll miss the dust that remembers motion. Beyond certainty lies the space where discovery begins, and that space is where 3i Atlas quietly waits. We've walked the known paths. We've tested every natural explanation. We've questioned propulsion, outgassing, comet tails, and dust vents. We've traced photons and sunbursts, gravity and geometry. And yet, something remains. Something still doesn't add up. Not because we lack data, but because we may lack language. Welcome to the edge of the map. Here, science doesn't end. It shifts from equations to hypotheses, from proof to possibilities, from what is measurable to what is barely conceivable. Let's begin with the invisible. Dark matter, the ghost fabric of the cosmos. It shapes galaxies, bends starlight, and fills 85% of the universe. We don't know what it is. We've never touched it. But we know it's there because it tugs on everything else. Now, imagine Atlas passing through a cloud of dark matter clumps, just dense enough to shift its path without a visible cause. Implausible? Maybe. Impossible? No. Next, modified gravity. Some scientists argue that gravity itself is incomplete, that Newton and Einstein described only part of the truth, the part we see. What if, at interstellar scales, gravity bends in slightly different ways? What if Atlas is obeying a version of gravity? If we haven't discovered yet, one that twists space in ways we mistake for acceleration, and then the truly exotic, ideas that shimmer on the edge of legitimacy. Hitch, fifth forces, quantum drag, unmodelled inertia, emergent space-time, each a theory proposed to explain. Anomalies just like this, each dismissed by many, but not by all, each waiting for one piece of evidence, too strange to ignore. 3i Atlas could be that piece, not because it proves anything, but because it doesn't fit, because its behaviour defies the playbook without breaking the board. That's where revolutions begin, not in chaos, but in patterned contradictions. There's precedent for this. Einstein's theory of relativity was born, not from wild imagination, but from a small problem. The speed of light never changed. It was an anomaly, a quiet, stubborn, inexplicable truth, and it forced physics to transform. Could Atlas be the same? A minor object, barely glowing, moving silently, and yet every orbit it curves, every vector it refuses, every alignment it honours, challenges something we thought we knew. We must ask, what if 3i, Atlas, is not a messenger, but a mirror, reflecting not the presence of aliens, but the limits of our models, a reminder that we see the universe through tools we built, and those tools have blind spots. This is not a call to abandon reason. It's a call to extend it, to admit that mystery is not failure, it is fuel. The universe has always hidden its deepest truths in places that feel slightly off. The orbit that doesn't match, the star that flickers wrong, the particle that spins the other way, and the object that moves without a cause. We are trained to look away from the strange, to file it under error bars or experimental noise. But the frontier doesn't fear the strange. It feeds on it. It maps the edges of belief and asks, what if we're the ones who hasn't caught up yet? Even now, there are physicists rebuilding equations to allow for unmodelled forces, not because they're certain, but because they're curious. Some call it fringe, some call it brave, but science doesn't care what we call it. It only asks, what explains what we see? And what we see in Atlas isn't conclusive, but it's inviting. It dares us to reconsider, to step beyond the last verified formula and ask, what if the next equation is still waiting to be imagined? The truth is, we're always dancing on the edge of the unknown. That's where every telescope points. That's where every question begins. And if Atlas has done anything, it's given us a reason to ask harder questions, because the greatest discoveries don't come from answers. They come from the courage to say, I don't know, but I want to. The hardest data to interpret is ourselves. We launch telescopes to decode distant stars. We build machines to track faint light. We simulate gravity, plasma, pressure, and dust. But when faced with uncertainty, the true variable is not the comet, it's us. What happens when a mystery refuses to shrink? When no amount of math can you seal it shut? We begin to reveal our deepest selves, not through facts, but through how we respond to the absence of facts. Some choose wonder. They lean forward, eyes wide, hearts open. They say, this is why we look up, to remember we are not finished. They find beauty in the unanswered. They call it sacred, not because it's divine, but because it's alive. Others choose fear. They grip tighter to what they know. They say, this must be explained or dismissed. That's many 20-40-40, because uncertainty feels like chaos, and chaos threatens control. Some dismiss the whole thing, a glitch, a gas puff, a rock in a weird spin, because that's easier than facing the implications. What if it's not natural? What if it's not explainable? What if it's not about us? What if we're witnessing something that was never meant to be noticed? Yet somehow, we were the ones who looked up at just the right moment. That possibility divides the mind. It tempts the soul, because if we're not alone, we're also not in control. And for a species built on prediction, on cause and effect, on mastering nature, that's terrifying. So we stand at a threshold, not of technology, but of identity. This isn't just a scientific story. It's a human one. A comet moves, without explanation, and suddenly we are the ones being observed. Are we ready to look at the mystery and not flinch? Can we stand in the presence of an anomaly and still say, I am willing to not know, because that's the door to everything we've ever discovered, from fire to fusion, from stone tools to space telescopes. It always began with not knowing and the courage to admit it. But modern humans aren't comfortable with mystery. We want answers fast, definitive, peer-reviewed. We want to look at 3I, Atlas, and say, comet, rock, debris, because ambiguity feels like weakness, and yet ambiguity is the birthplace of truth. Every major shift in human knowledge came from discomfort. The earth moves, time bends. Particles exist in two places at once. We didn't want to believe these things. They hurt. They forced us to abandon comfort for a higher clarity. And now, 3I, Atlas, offers the same invitation, not to fear, but to transform. Perhaps that's the real gift of interstellar visitors. Not data, not evidence, but mirrors. They reflect our assumptions. They reveal our intellectual ceilings. They show us how quickly we rush to label what we barely understand. So let's pause, not to decide, but to feel, to acknowledge what this moment reveals about us. That we are still children, in the dark, brilliant, curious, afraid, resilient, looking up because something inside us still remembers the stars. What we do next will define more than theories. It will define what kind of species we are becoming. Are we the kind who silences anomalies, or the kind who chase them into new worlds? Maybe 3i, Atlas, isn't here to tell us something. Maybe it's here to ask us something, not with words, but with its silence, its impossible trajectory, its refusal to explain itself. Maybe it's asking, are you listening? Not with instruments, but with imagination. Not with models, but with humility. Because at the threshold of every great discovery is a question no one dared ask out loud. What if this is real? What if we're not ready? What if readiness has never been the point? To be human is to reach beyond what we can prove, to dream into what we can't yet define, and to recognize that mystery is not the enemy of knowledge, it is the seed of it. So here we are, standing at the edge of something ancient and perhaps intelligent, or perhaps just perfectly odd, and the only thing we know for certain is that we are not certain. But maybe that's enough. Maybe that's exactly what it means to be alive in a universe still unfolding. The universe never hides. It only waits for us to grow quiet. We chase comets, chart their spin, analyze their speed and demand. They tell us who they are. But some stories don't speak in words. They speak in person, in alignment, in the absence, in silence. For months we've asked, what is 3i, Atlas? Is it a spacecraft? Is it a rock? Is it proof of something more? We've turned our instruments toward it. We've debated in papers, podcasts and press rooms. We've watched it refuse to behave. And, in its refusal, we found ourselves facing a deeper truth. The mystery is not in the object. It's in our reaction to it. Because not every riddle needs a solution. Not every anomaly needs an answer. Some exist to mark the edges of what we know, to say, this far you've come, and beyond this, you must change to go further. That's what this object is. A map, not one drawn in ink, but in questions, not one we can fold or hold, but one that unfolds us. It shows us where science reaches, its current horizon, and then it waits. There's humility in that, to admit we do not know, to whisper, maybe we're not meant to, maybe not yet, maybe this moment was never about 3i, Atlas, at all. Maybe it was about learning to listen when the universe speaks without sound. Think about it. All the data, all the observations, all the light curves and force vectors, and still, the most truthful thing, we can say, we're not sure, and that is not failure. That is the threshold of growth. Because what if meaning doesn't always follow clarity? What if some things are meant to stay luminous and incomplete, not to frustrate us, but to elevate us, to remind us that knowledge isn't the only form of truth, that awe is a kind of knowing too. We are creatures of sound, of a story, of structure, but the cosmos, it speaks in magnetism, motion, and quiet. And if we cannot match its quiet, we may never hear its most beautiful secrets. There is a place, in science, in philosophy, in the human heart, where silence is not an absence, but a presence, a deep, still presence that holds everything we're not yet ready to name. So, what do we do? With an object like 3i, Atlas, we've studied it, argued over it, projected hopes, fears, and futures onto it, and now it begins to fade. Its light receding beyond our telescopes, its motion carries it into the deep, and yet it remains, not in our databanks, but in our awareness. It leaves behind a gentle pressure in the mind, like a story that ended before the last page was turned. But maybe the ending, it wasn't the point. Maybe the silence is the last page, and we were meant to sit with it, not to solve, but to understand, not to answer, but to accept. In that acceptance, we are changed, not with conclusions, but with new forms of attention, new questions, new stillness, new space for mystery to bloom. It's easy to think the universe withholds itself, that it hides, but maybe the truth is more tender than that. Maybe the universe never hides. It simply waits, not for better tools, not for bigger budgets, but for quieter minds, for the kind of stillness that can finally hear what the data cannot say. So tonight, let us be still. Let us let go of the need to decode every flicker of light. Let us soften our gaze and feel what this mystery has already given us. A renewed humility, a deeper awe, a reminder that not knowing can be sacred. 3. Atlas moves on. The headlines fade. The models go still. The community waits for the next signal, the next light curve, the next anomaly. But somewhere inside, a quiet voice remains. I was here. I moved in ways you didn't expect. And that movement, I moved you too. That's the real discovery. Not what we found in space, but what we found in ourselves. Not data, but depth. Not certainty, but presence. The story doesn't end with answers. It ends with awareness, with the soft realization that every mystery has a rhythm, and if we listen carefully enough, it becomes a song, one we don't need to sing, only to hear. Let that be enough. Let the silence be, not the absence of meaning, but its final form, the stillness, where we meet the unknown, not with fear, but with reverence. The universe waits for us to grow quiet, to step past the noise, the debate, the doubt, and simply be present with the beauty of not knowing. When the noise ended, the stars kept whispering, not in shock, not in theory, just in rhythm, as if they had always known we'd return to this silence. That, after all the questions, the diagrams, the debates, we'd remember how to listen without needing to name. The storm had passed, not the cosmic one, the one inside us. The flurry of speculation, the urgency to decode, the tidal pull of needing to know before it vanished. It all began to still, and in that stillness, a new texture appeared. Reflection. What do you see after you've stopped looking? What remains when urgency dissolves? Sometimes the gentlest moments arrive after the last explanation fades, not because they answer anything, but because they allow you to exist without defending what you know. That's how the universe speaks, when it becomes gentle again. No pronouncements, no breakthroughs, no grand curtain pulls of truth, just the quiet of a night sky that no longer asks to be solved. We had chased 3I, Atlas, like a ghost, trailing breadcrumbs of physics, and when we finally arrived at the edge of understanding, it offered us nothing, not out of cruelty, but out of grace, because it knew what we didn't. That is the final gift, was not a revelation, but a release. The release of pressure, of needing to be first, or right, or complete. And in that release, we remembered how wide the sky truly is, how small we are, and how beautiful that smallness feels when it's not shameful, but sacred. On that final night of observation, there were no announcements, no declarations, no new data points that changed everything, only the feeling of presence, of being here with a mystery that had stopped trying to be seen. That's what made it real, not the numbers, not the thrust vectors, not the orbital charts, but the hush it left behind, like the air after a storm, still charged but settling. It takes courage to be quiet after the questions, to let the echo fade without chasing it, to let the story end before your mind is ready. But the universe is patient. It has waited through billions of years of silence to meet you in this moment. It will not mind if you pause. So pause, take in this quiet, let the residue of wonder settle behind your eyes. Let it glow, not with answers, but with openness, not with belief, but with peace. Do you feel it? The slowing of mental orbit, the softness creeping into your pulse, the unspoken agreement between you and the stars, that tonight you do not have to solve anything. You only have to be, and being is enough. Breathing, noticing, resting with a sky that watches without judgment, and a universe that keeps unfolding, whether you understand it or not. 3I, Atlas is gone now. Its trail, a fading memory, on screens gone dark, but in its wake, something remains, a hush, a clarity, a sense that perhaps the cosmos is not cold or chaotic, but kind enough to nudge us gently, when we're ready, kind enough, to offer mystery without punishment for not solving it, kind enough to echo our awe with its own stillness. This gentleness is not a weakness, it's the strength to release what cannot be held. It's the wisdom to stay soft in the face of the unknown. It's the grace of knowing you don't need to dominate a truth for it to change you. So tonight, as your thoughts quiet and your breath slows and the sky stretches wide above you, let yourself be held by that gentleness, by the silence that comes not after the discovery, but after the need to discover has passed. This is the gift we didn't ask for, not proof, not certainty, but peace. A peace that whispers, the universe doesn't require your understanding, only your presence. Somewhere out there, 3i, Atlas continues, on a path no model could predict, but its direction is no longer ours to trace. It belongs to the dark now, to the silence, to the vast, and maybe that's exactly where it was always meant to go. And us? We remain, not untouched, not unchanged, but quieter, softer, more ready to receive what comes next, not with answers, but with openness. Let the universe be gentle with you. Let it be the slow tide against your thoughts. Let it rock you out of the gravity of needing into the stillness of simply being. When the noise ended, the stars kept whispering, and finally, we remembered how to listen. The object fades, the universe exhales, and so do we. No longer reaching, no longer scanning the dark for clues, vectors, signatures, just being, just breathing. The chase is over, but something deeper has begun. The silence left behind by 3i, Atlas, is not empty. It's full of gentle rhythm, like a tide beneath the stars, pulling us inward, into the current of belonging. The story that began with a question ends not with an answer, but with a sigh. We once asked, why is it moving? Now the question feels smaller and softer, replaced by a feeling we can't explain, but know completely. A knowing that doesn't need words, like the hush of snow, like the warmth of breath on glass. Out here, beyond certainty, beyond control, there is stillness. And in that stillness, there is peace. You don't have to hold anything, not the data, not the fear, not even the awe. Let it all rest. Tonight, the sky is not watching you. It's welcoming you into a rhythm older than thought, deeper than theory, wider than anything we've ever built. Not a calculation, not a destination. A home. Do you feel it? The release of every tension. What you didn't know you were holding, the way your shoulders lower, your thoughts soften, your breath deepens, just from hearing. The stars go quiet. This is what it means to sleep beneath the stars. Not just to lie beneath them, but to belong to them, to let their light wrap around you like a blanket woven from memory and possibility. To feel, for once, not like an observer, but like a part of the cosmos itself. All your questions can wait. They're not going anywhere. The universe holds them gently now, like a lullaby without lyrics, rocking your mind into the cradle of the unknown. You're safe. You're small. You're not alone. Somewhere, light from a star you'll never see is crossing the distance, just to be here, just to join this quiet, this exhale, this moment, and that's all we are now. Moments. Not answers, not names, just moments of being in rhythm with everything else that breathes. The last signals from 3i, Atlas, have faded into noise, but its gift remains. A reminder, we don't need to solve the sky to sleep beneath it. We just need to trust that we are part of its unfolding. So rest, not because the mystery is over, but because it no longer owns you. You've released it, and in doing so, you've made space for something softer. Let your mind float. Let your thoughts dissolve, like mist over a quiet lake. No need to chase the stars tonight. Let them come to you, like they always have, like they always will. There is no threat here, no urgency, no deadline, only the slow spin of galaxies, carrying your heartbeat into the fold of forever. And it's enough. The breath you're taking now, it echoes in the rhythm of planets. It mirrors the pulse of something vast and kind. You don't need to understand that. You only need to feel it, to let it lull you into the peace that doesn't ask for comprehension, only presence. This is your place in the cosmos, not as a decoder, not as a theorist, but as a dreamer, as someone who dares to close their eyes and feel the universe, move around them. That's where wonder lives, not in the tension, but in the surrender. The stars are whispering still, but now they're not asking. They're singing, and you are finally quiet enough to hear them. The night stretches on, but it no longer feels vast. It feels familiar, like a hand you forgot you were holding, like a lullaby you always knew, but never heard until now. Let yourself drift, beyond the comet, beyond the numbers, beyond the need to explain. Let go. Let the story dissolve into rhythm, into sleep, into belonging. And when you wake, the stars will still be there. So will the questions, and so will the silence. But something in you will have shifted, softer, calmer, ready to wonder again, not to control, but to marvel. So now, let the dark cradle you. Let the sky remind you what peace feels like when it's cosmic, not conditional, when it doesn't ask anything of you except that you rest. Tonight, the object is gone, but the echo remains, not in your mind, but in your body, in your breath, in your slowing pulse, in the quiet you carry now, like a gift no one can take away. And as your eyes close and your thoughts scatter, like dust in starlight, remember, the object fades, the universe exhales, and so do we. Sleep well under the quiet sky that never needed to be solved, only witnessed, only shared, only felt.